Hello, this is Dave Ferris. I'm going to walk you through problem number 5 from the 2022 AP Statistics exam. Problem number 5 is designated every year as a multi-focus problem, which simply means that students will be exposed to several skills that they will need to demonstrate on number 5. The 4 skills in AP Statistics are selecting statistical methods, data analysis using probability and simulation, and statistical argumentation. And I believe there's a little bit of all 4 of these in this particular problem. Also a reminder that every part, in other words, part A, part B, and part C, every part on an AP Statistics exam is scored on a 3-letter basis. E stands for essentially correct. It has all the essentials of a correct response. P means partially correct, which means there's usually one thing either omitted or one thing that's incorrect. And then I is incorrect, which typically is 2 or more things that are just not right about the problem. And then when you add these up, 3 E's are going to be a score of 4 on the problem. 2 E's and a P in any order are going to be a 3 overall on the problem. There's a lot of combinations that'll give you a 2. Basically 2 E's and nothing else, or 3 P's. And then anything less than that would be a 1. So let's dive into a student sample that has full credit. There should be a link in the comments section if you used a YouTube link to this document. This document is the 3 student samples that are available on the College Board website, so that would be an alternative method of getting these. Every year they publish 3 student samples for every problem. And so we're going to start by looking at a student that got a 4, which means they got all the credit that was possible on number 5. And we'll use this as our way of unpacking the rubrics for problem 5. So to start out with, assuming you've already read through this problem, you should hopefully have some familiarity. So the very first part, I'm going to try to do this in a sort of a checklist fashion. For part A, the students were supposed to determine and compare the medians of these 2 groups. So the very first thing that they should do is calculate the medians correctly. The medians are 7 and 0. And if you look at the rubrics carefully, you'll find out that they actually give them some wiggle room on these, which is interesting because as a teacher, I would not give them any wiggle room. It seems like medians are pretty explicitly calculated. But for 7, they just had to make sure that they provided an answer somewhere between those 2 dots, which I believe were 5 and 8. And for the 0 answer, as long as students had a number between -2 and 2, they gave them credit for that. I believe most students that I've seen answer this will get a 7 and a 0 and be spot on. So that's the first piece that they have to get full credit. The second piece is they have to compare. And as you may know from other problems where students are asked to compare, they have to use pretty specific language like greater than, less than. They cannot just state 7 and 0 and expect the reader to understand that 7 is higher than 0. So students do have to use comparative language to get that credit. Step 3 for full credit is context. And the context in this problem is reduction in blood pressure. It's basically the variable that's being measured in this problem. So they needed to talk about reduction in blood pressure to get the context. And the rubric also said they must include both dark and white chocolate. And from what I've seen, it looks like students kind of put that in automatically. So I would be surprised if too many students left that out, since that's really part of the full description that they need to have there. So for part A, students have to have all 3 of these to get full credit. If they had 2 of those, they would get a partially correct. And if they only had 1 of those 3, that would be an incorrect response. Moving on to part B. In part B, there are 3 things as well that students must have to get full credit. Number 1, they have to talk about sampling variability, would be one way to say that. This one is a little harder to grade because it's verbal and there's so many ways students can communicate this. They have to somehow communicate clearly that this difference that they found could be due to, again, you could call it sampling variability, you could call it variability from one sample mean to another sample mean. They could talk about the variability in the sampling distribution as being a reason why maybe this result was really not significant. So there's lots of ways students can communicate that, and there are some more details in the scoring rubric. But generally, they just have to talk about the sampling variability. In step 2, students have to talk about the concept that this difference could just be by chance, just by random chance. So there was a difference of 5.66. That difference could have been simply by random chance. It doesn't have to be a true difference. And so they had to suggest that possible explanation. And then in part 3, the third piece to get credit, they had to suggest that to really know for sure whether this is a true difference or whether it's just a random difference, there would have to be some sort of inference procedure conducted. So they have to suggest that to really make sure that this is a real difference, some sort of a test would have to be conducted, an inference test, hypothesis test. Now what's interesting is in the rubrics for this one, students only had to get 2 out of these to get full credit. So if they got 2 out of these 3, or they got all 3 out of these 3, that was given an E. If they got 1 of these 3 things, that was a P. And if they got none of these 3 things, that was an I. This is a little different than what we see in some scoring rubrics for problems. So they gave them some leeway, I guess you could say. They gave students some leeway on this. And so as long as they had 2 out of these 3, that was going to be scored an E. Now let me go back. I actually forgot to officially score this. I was going to show where this student had all 3 things. So let's go back and make sure we can see where students got this full credit. So the first part, on part A, they had to calculate that for dark chocolate it was 7 and for white chocolate it was 0. They've got that exactly correct. So they've got the first part correct. For the second part, they had to compare using comparative language. And if you look, there's the word higher. They kind of added some words in there to make it sound good, but they did say that the dark chocolate, which is 7, is higher than the white chocolate, which is 0. So they got the comparison piece. And then they had to talk in context, which was the reduction, the mean reduction. Okay, they've got it up here too. The mean reduction or median reduction in blood pressure. So that was the component that is the context. It's the variable that's being measured. So this student got all 3 pieces, and so they scored an essentially correct for part A. Scoring part B, did they talk about sampling variability or the variability from one sample to the next? And yes, they actually used that phrase, sampling variability. And so they got the first component. They talked about the sampling variability could account for the variation. And they also mentioned that chance was an explanation for the variability of 5.66 that they got. And then they did suggest, actually, that something about rather than a real statistically significant result. So even though they've already got the credit for an E, they did actually have the inference suggestion that there needs to be a statistically significant result to be sure that the difference is real. So whether you score that as a 2 or 3, it doesn't really matter. They got enough to earn an essentially correct for part B. And now if we go to part C, a simulation was done. 120 trials were done, and these were all simulated differences. Now remember, the difference that they did get on the previous part was 5.66. So we're thinking about a difference of 5.66, and they were supposed to compare that to the distribution of these simulated differences. And so for this piece, there were 4 components that they wanted students to address. So the first thing is they were supposed to use the results of the simulation to determine whether this is statistically significant or not. And so anytime they are told to use something in their answer, they must. And so they were supposed to calculate a p-value, and the p-value in this problem was 0.025, which kind of goes hand in glove to how they got that. They would get that by taking 3 divided by 120. So they've divided this into two pieces. One is the p-value, the probability of getting a result this high or higher. 5.66 is somewhere in there. And so you'll notice there's 3 dots above that, which is basically the p-value for this simulation. But they also have to have the work. And so the work and the answer are both required. These are considered 2 pieces of the 4 pieces that students have to get full credit. So they must have the work and they must have the p-value of 0.025. What you will find is some students actually did a test somehow and calculated a p-value. I don't know if they typed all the numbers in their calculator or what they did, but that of course is not from the simulation, and so they cannot get, probably they can't get at least part of those two pieces. Part 3 is the conclusion. They have to make a conclusion that there is a statistical difference because the 0.025 is less than 0.05. And so again, part 3 and part 4 are kind of typically linked together. So part 3, they had to say there is statistical significance, or there is a difference, a true difference based on the p-value, and it's because the p-value of 0.025 is less than the alpha level of 0.05. So the linkage is really the fourth part, linking the conclusion that there is a statistically significant difference to the fact that the p-value calculated is less than alpha, which is 0.05. And 0.05 was given in the stem of the problem. They had a 5% level of significance. And so 3 and 4 kind of go together as well. They have to have the linkage and they have to have the correct conclusion. So these 4 pieces are the things that students have to get full credit. So let's see how this student got all 4 pieces. First of all, they calculated the p-value correctly. So these are 2 pieces of the credit right here. So the work and the p-value are both right there next to each other. And then they mentioned that 0.025 is less than alpha, which is 0.05. So they've got the 4th component. So they've got the first component and the second component already. And they've got the 4th component of the linkage. And then they said here, if you read, to conclude, the dark chocolate will result in greater blood pressure reduction than white chocolate. So they rejected the null. They kind of set it up as a hypothesis test. But they got the statistical significant difference in there somewhere. And so they were 4 for 4. And so they earned an E on this part. So that's how a student earned EEE, which is an overall score of a 4 on this problem. One thing we need to add, though, in the notes here is they have to be 4 for 4 to get an essentially correct for this problem. But what's interesting in the rubric, if students got 2 or 3 out of 4, they got a partially correct. So even students that only got half of these correct will still earn partially correct. And what you'll see a lot of times is students did not use the simulation, and so they got, sometimes they missed 2 pieces on here just because they didn't use the simulation, but they showed enough statistical skill and knowledge that, you know, they are still earned partial correct, which is probably a fair way to score this. So that's what it looks like to get a 4. Not too many students, I don't think, on this one. Multi-focus problems tend not to be high scoring, and so not many students got a 4, but this is one example. So now we're going to look at a student that got a 3 and a student that got a 2 on this. And so best practice would be to pause the video at this point, and then once you have scored this problem, turn it back on, and I will show you how this student got a 3. Basically, they just missed one thing, or they omitted one thing that's important. So push pause and then come back to this. Okay, so if you scored list, let's see if you found the piece that was missing. So for scoring part A, we're looking, the first part, we're looking for the 7 and 0. And so it looks like they've got the 7 and they've got the 0. So the first part is correct. The two medians were calculated correctly. The second part is to compare them explicitly, and they said dark chocolate had a higher median blood pressure reduction, so they got that, and the blood pressure reduction also got the context. And they did talk about dark and white chocolate, and so they had everything they needed to get an E. So part A was an E. In part B, we're looking for some talk about sampling distribution or talk about how the variability from one sample to another can be different. And if you read through this, there's no commentary, there's no mention of the different variability from one sample to the next, and that this could then just be random chance. They did say the random chance part, so they got that part correct. And they did say that a test must be conducted. So basically they got 0.3 that we were looking for, and they got 0.2 that we were looking for. But 0.1, where there was some description of the variability from one sample mean to another sample mean, that piece was not there at all. However, they still got 2 out of the 3 parts. And so if you remember that little caveat, 2 out of 3 parts on part B still earned an E. So this student has already earned 2 E's, and they're on track to get a 4 if they don't mess up part C. But since you know they got a 3, I guess you know the problem lies in this particular piece here. So if you read through this, you'll notice, they're setting up like a test, and it does not look like they're using the simulation. And so sure enough, when you see the p-value is coming from apparently a test that they set up somehow. And so they cannot get credit for the first part or the second part because they don't have the work there, and they do not have the p-value that's correct, which should be 0.025. So they missed both parts of this. Part 3 was using the p-value they had and saying that it's less than alpha, and so then there is convincing evidence that there is a greater reduction in blood pressure in dark versus white. So in part 3, they did actually earn that credit in part 4. So since they got half the credit, they still earned a partial overall for part C. So this student overall had 2 E's and a P, and 2 E's and a P is a really good score on a problem like this. And they earned a score of 3. So I think that was a fairly common thing on part C, is where students just didn't even know, either they didn't know how to use the simulated results or they just didn't read carefully. But they still, this person still got a decent grade. All right, the last one. This student got a 2 out of 4. So again, best practice, if you push pause and go through this, see if you can find the mistakes that are throughout this problem, and then I'll wrap this up. All right, so on the third student, it turns out that there is a problem, an issue in each of the 3 parts. So this student ended up, I'll just go ahead and put that up here. This student ended up getting 3 partials and an overall score of a 2 because of 3 partials. So let's see what's missing in all 3 of these. So part 1 was the 7 and the 0. They do have that. They calculated that correctly, so that is not a problem. Part 2 was supposed to compare. And this is one of these typical things you see a lot, is where students will give the numbers and I guess just expect the grader to figure out that 7 is higher than 0, but it is not explicitly mentioned. They do not say that the dark chocolate had a higher median than the white chocolate. Now they did say reduction in blood pressure, so they got the context on that. So on this part, they had to get all 3 pieces, and they only got 2, so that was a partially correct response. In part B, we're looking for the first part that we're looking for is that they are talking about sampling variability and somehow. And if you read through that, there's no mention of the means varying, and there's no mention that this difference of 5.66 could just be from random chance. So students didn't get either one of those. Then there's no talk about the variation or the variation in the sampling distribution. And there's no mention of that this could just be a chance difference. In part 3, we're looking for the fact that inference is needed. And so they did mention that without a proper significance test, there's no way to make a definite claim. They did nail that. And remember, on this one, if they got 2 or 3, that's an E. And so if they get 1 out of 3, that's still a P. So even though they only got one piece of these 3, they still earned partially correct score for this. And then finally, what you'll notice again, they did some sort of crazy calculation of 61 out of 120 to get the p-value. And so they did not use the simulation. And so the very first thing that we're looking for is that they calculated the p-value correctly. So part 1 is not true. They did not calculate the p-value correctly. But here's what's interesting in the scoring. This is the p-value they got. That is not the correct p-value. But notice what they did do. They showed the work. And that would be the correct work for that wrong answer. So what's kind of cool about rubrics, generally speaking, they do not double ding students. There's no double jeopardy. And so this student actually got credit for part 2, even though they got the wrong p-value. And then when they took that p-value, notice what they did. Again, once they made the claim that 0.5 is the p-value, well, then we grade this based on that. And so did they take this p-value and do the right thing? Well, they failed to reject since the p-value was greater than 0.05, which is the alpha level. So believe it or not, they ended up getting 3 out of the 4 pieces on this problem, even though they did not calculate the p-value correctly. So this student, 3 pieces out of 4, is still a partially correct answer. And so that's why they ended up getting 3 P's, which is a 2. One final little tidbit on this problem, just FYI, the overall global mean for this problem, believe it or not, was 0.87. The global mean for this problem is 0.87. That's for a couple hundred thousand, 120,000, 140,000 students. So 0.87 out of 4 was the global mean. So all of the students that we just scored, that got 2 or 3 or 4, actually did very well and are above average. And this problem in particular was difficult, challenging for students. And so can be a little tough to grade as well, especially those parts where they have to write a lot. But hopefully the checklist system will serve you well and you'll be able to score fairly accurately. Don't be afraid to use professional judgment. Sometimes there's just not a specific kind of unicorn situation a student might write. And so a lot of times you just have to use your professional judgment. And basically it just comes down to, was the communication clear enough to you as a stats teacher to know what they meant? And that's kind of how we roll when those unusual things come up, especially when we don't really have all the details that a regular reader would have in the summertime. So good luck with that. Hopefully that was helpful.